units. That is the general science and ability paper portions from physical science. Here you can see in the syllabus. So what is astronomical system of units? First of all, I will explain you what is units, and then we will explain what is astronomical system of units and why we use astronomical system of units instead of basic units like that of kilometers. So what is unit in physics? In physics, unit is a standard with which you can measure a quantity, with which you can measure something. It is called units. These are 7 basic SI units. Second, which is used for time. Meter, that is used for length. Kilogram, used for mass. Ampere, used for current. Mole, used for amount of quantity. Candela, used for light intensity, luminous intensity. And Kelvin, used for temperature. These are 7 basic SI units. So units are the standards with which you can measure physical quantities. Now, if you want to measure some things, like you want to buy 1 kg sugar or 2 kg sugar from a shopkeeper, so you will ask him that give me 2 kg or 1 kg, whatever amount you want, sugar. So he will measure that sugar with some standard. So the standard here used will be a kilogram. So standard with which things are measured called units. Now, what are astronomical system of units and why we need astronomical system of units instead of these basic units? Astronomical system of units are collection of units. You can also say astronomical units, or in short we write it as AU. Collection of unit which is commonly used in astronomy to measure distance within our solar system and beyond. We use astronomical system of units to measure the distance within our solar system and beyond our solar system. These units are based on the fundamental properties of celestial bodies and the dynamic of their orbits. Now the question is why we use astronomical system of units instead of as we use kilometer, meter or miles to find the distance. As astronomical system of units are also used for the distance, so why we use astronomical system of units instead of basic SI units like meter, kilometer or mile? It is because in astronomy the stars, planets are very far from us, so it will be difficult for us to calculate this distance in meter, kilometer or mile, because it is too much distance. So that's why we use astronomical system of units. Now what is astronomical system of units? Astronomical units is the average distance between the earth and the sun. The average distance between the earth and the sun. So the distance, or you can also say simply you can define it as the distance from the earth to the sun. Earth to the sun distance is called 1 astronomical unit. Now here it is a basic standard. The distance from earth to sun will be called 1 astronomical unit. Now if a distance greater than that distance, it will be multiplied with the numbers. Its value is approximately 149.6 million kilometers. So just imagine if 1 astronomical unit is 149.6 million kilometers, then how can we measure such a distance in kilometers? So that's why we use astronomical units. We use astronomical units to measure the distance within our solar system, especially for planets and other objects around the sun like stars, etc. Now the second thing is light years. What is light years? Most of the people confuse with it, and they consider it as the unit of time. Light year is not the unit of time, it is the unit of distance. Light year is a unit of distance used to measure interstellar and intergalactic distances. Means we can find the distance between the stars with light years. Light year is actually a unit. It represents the distance light travel in 1 year. In short, you can say light year is the distance light travel in 1 year. Simple definition: light year is the distance light travel in 1 year. It's called light years. The distance light travel in 1 year is 9.5 trillion kilometers. This is the distance which the light can travels in 1 year. Next, another one unit is parsec. These are astronomical system of units. In astronomical system of units, we use AU, that is astronomical unit, which is the distance between Earth and Sun, and light years. We also use an astronomical system. So collectively these units are called astronomical system of units. And visually you can say light years, parsec, or astronomical unit, but collection of all these units are called astronomical system of units, like that of SI basic units we use in physics, basic units, 7 basic units. So collectively these units are called astronomical system of units. Now what is parsec? Here in the graph you can see this is Earth, and this is Sun, and this is a star. So parsec we actually used to find the distance between stars and galaxies. Parsec is another unit of distance that is used in astronomy to measure the distance of star and galaxies. By definition, you can say the distance at which one astronomical units, as we have already studied in astronomical units, that the distance between Earth and Sun is called 1 astronomical units. So 1 astronomical units subtended at an angle of 1 arc second. Here is an angle, make an angle of 1 arc second, is called parsec. The distance at which one astronomical unit is subtended at 1 arc second is called parsec. 1 parsec is approximately 3.26 light years, or you can say 30.86 trillion kilometers. Now how to find the parsec? Here is the formula to calculate the parsec. Here you can see this is the Sun, and this is Earth, and here is the star. To find this distance is called parsec. Here you can see distance. This distance is in parsec. 1 astronomical unit, the angle subtended at 1 arc second is called parsec. This distance is called parsec from the Sun to stars. Now to find this distance, as we already know, 1 astronomical unit is 1 astronomical unit is the distance from the Earth to Sun, and to find 1 parsec, we have to find a parsec that is by definition equal to 1 astronomical unit or 1 arc second, as 1 arc second and 1 degree 3600 arc second. So if you want to find 1 arc second divide both sides by 3600. You will find 1 degree over 3600 is equal to 1 arc-second. But as we already know that a degree is equal to pi over 180 radians, if you want to find it in radians, so put pi over 180 radians instead of degree. So you will get 1 arc-second is equal to pi over 3600 multiplied by 1 over 80 radians. Now find these values here in 1 arc-second. So you will find 1 parsec is equal to 3600 multiplied by 180 divided by pi AU. So find it by multiplying it and then divide it by pi, you will get this result. So 1 parsec is equal to 2 multiply 2 into 10 to the power 5 astronomical unit. 1 parsec is equal to 2 and approximately 2 into 10 to the power 5 astronomical unit. There are some other units in astronomy we use, like solar mass. Symbol we use for solar mass is the symbol we use is M into a dot and a circle. So solar mass is the unit of mass used in astronomy to express the mass of celestial objects like stars, galaxies, or stellar clusters. By definition, you can say the mass of our sun, which is approximately equal to 1.9 or 2 into 10 to the power 30 kg. So why we use solar mass? We use solar mass to express the mass of other celestial, means heavy object like stars and galaxies, etc. To find the masses of these objects, we used solar mass. Parsec, light years, and astronomical unit we use to find the distance between these objects, while solar mass is used to find the mass of the other objects. There is a big difference between these units. Parsec, light years, and astronomical unit are used to find the distance, while solar mass is used to find the mass of star and other heavy objects. Here is a diagram you can see, but it doesn't mean that you can use a spring balance or other type of balance to measure to keep sun in one side and other object on the other side. It is just for explanations. There is a formula which you can use to find the mass of other objects by taking mass of the sun. Similarly to solar mass, there is another unit that is called earth mass. We use same symbol, but instead of dot and the circle, we use the plus symbol. Earth mass is unit of mass to express the mass of planet, moon, and other smaller celestial bodies, while solar mass is used for large celestial bodies. It is defined the mass of the earth, that is about 6 into 10 to the power 24 kg. As you can use this formula, take 1 m is the mass of the earth, as we already know force of gravity. So if you know the distance, r here is distance, so you can easily find the mass of the other objects. Thank you for watching this videos, and if you have any type of confusion or you want video lecture on some specific topic, kindly ask in comment section, and please subscribe to my channels. Thank you for watching.